All right, here we go. So, yeah, lots of triangles going on here. So, let's write down our givens and we'll try to make sense of all this. So side AM is congruent with side MB or segment MB. So, given. So, let's see. AM is congruent with MB. All right, it's easy enough. And then AD is congruent with BC. So AD right here is congruent with BC right here. And then we have angle MDC is congruent with angle MCD. MDC congruent with MCD. Okay. All right. So let me take this triangle MDC out of the picture just for a second. So let me bring it over here. So MDC. I don't think we'll need it for a long time, but so we know that these are congruent, right? So if two angles are congruent, we can use the converse of the isosceles triangle, right? The converse of the isosceles triangle theorem. And so we can say that DM is congruent to CM, right? DM is congruent to CM, and that's by converse of isosceles triangle theorem. Okay. All right. Now, let me just stop for a second. What we're trying to prove is that AC is congruent to BD. So AC is this one here. I'm trying to prove that's congruent to BD. Okay. So I'm thinking that I'll probably have to get this triangle and this triangle congruent, right? And then I can do CPCTC. And we have an okay start with that, right? Because we have that. They also share a side, so we can use something there. And so really, if we can find one more side or an angle somewhere there, then we can prove that those are congruent. Okay. All right. So what I'm trying to do now with this is I have this side congruent with this side, right? And then we have this side congruent with this side. So what I'm looking at is now we just prove that this side MC or CM is congruent with DM, right? And so now we have these two triangles congruent, okay, by side, 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 right? So I can say that triangle MAD, triangle MAD, is congruent with triangle, let's see, M corresponds with M, A corresponds with B, and C corresponds with D. And that's by SSS. Okay. So how does that help us? Well, like I said, we hope to prove that, or I think it'd be beneficial to prove that this triangle is congruent with this triangle, right? Or actually, we could prove that this triangle is congruent to this triangle. So there's a few different ways we could do it. We could either do ABC. Let me do a better job of that. We could do BCD with ADC, which is what I was thinking originally. Or we can do BDA with ACB, okay? All right, I had to pause for a minute, but I think I found even a better situation. So what about DMB, right, which we already have two parts there congruent with AMC, right, which we have those corresponding parts congruent. Okay, so let me I kind of made a big mess here. Let me take that those triangles out. So we have AMC, right? And we know this and this, and then we have DMB. Okay, and with DMB, MB is congruent to AM, and DM is congruent to CM. Okay, all right, so now if we can prove that M is congruent to M, we can prove that the triangles are congruent, right? And then we can prove that AC and DB are congruent. Okay, so let's take a look at this. So so one of the angles is this angle here, right? And because we just proved these two triangles are congruent, we can say that angle AMD is congruent to angle BMC, right? So I'm going to say that. So angle AMD is congruent to triangle or to angle BMC, and that's by CPCTC. Okay. All right. So then we know that angle M, well, we know that angle AMC is the sum of AMD and DMC, right? So let me write that out. This is by the segment addition, or the angle addition postulate, excuse me. So angle AMD plus angle, and I have to use the measure of in this one actually, plus the measure of angle DMC is equal to the measure of angle AMC. Right, and that's the angle addition postulate. All right, and in the same way, I can say that these two angles are they add up to angle BMD, right? So I can say measure of angle BMC plus the measure of angle DMC is equal to the measure of angle BMD. Okay. All right, and we just proved that AMD is congruent to BMC, right? So we can say, let me change those into measures real quick. I could have done this here, but I can say measure of angle AMD is equal to the measure of angle BMC by definition of congruent angles, right? Okay, and now that I have this, now I can substitute AMD in for BMC, or the other way around, right? So I can say, okay, measure of angle AMD plus measure of angle DMC equals measure of angle BMD. And I use substitution property of equality there, right? Okay, so what I did is I put, I replaced this for this, right? Okay, so I rewrote this equation, but I put AMD in there for BMC because those are equal. And now I can see that, oh yeah, BMD, so notice how AMD plus DMC equals BMD, but AMD plus DMC also equals AMC. So that must mean that measure of angle AMC is equal to the measure of angle BMD, right, by the transitive property. And therefore they must be congruent. by definition of congruent angles. Okay. And since they're congruent, now we can say, okay, let's come back up here. So we just proved AMC is congruent to BMD. And so now we have side angle side, right? So we can prove those two triangles are congruent. So triangle AMC is congruent to triangle BMD, right? As that's the corresponding order. All right, and we said side angle side, correct? Yep. Okay, and so now that they're congruent, we can say, hey, well, that must mean CPCTC. We can say that AC is congruent to DB, and that's what we're trying to prove, right? AC is congruent to BD by CPCTC. All right, so there we go.